I study geology.
And I study geography.
And today, we're going to take you on a journey through the geological and geographical history of Kingston, Frontenac.
Let's go!
This is my younger brother, Tyler. Unfortunately, I haven't been able to film with my coworkers because of the COVID-19 pandemic, but I have been isolating with my parents and my brother at their house, which is why we're able to sit so close together without wearing a mask. So today, we're going to be learning about geology, geography, and paleontology. Let's review our natural sciences graphic real quick. These are all earth sciences. Remember that earth sciences have to do with non-living things and the forces of Earth. Geology deals with the study of rocks, minerals, and sediment. Paleontology deals with the study of fossils and ancient life.
And geography is a study of landforms, natural processes, and the way that the world moves.
Today, we're going to be taking a journey back in time through Kingston, Frontenac. I've heard it said that geologists, paleontologists, and geographers are like super detectives. They look for clues in the ancient past to help us solve the mystery of what might have happened. But before we can do that, you have to learn to think in geologic time. Check this out. What we call geologic time can be pretty hard to understand because there's just so much of it. It can be really hard for us humans to imagine 1 million years, let alone 4 billion. So I'm going to try to make all this as easy as possible to understand, and that means simplifying some things. So imagine that all of time on Earth is 1 day. It might help to notice that my graphic of all of time is shaped like a circle, the same shape as a clock. So let's put it next to a clock. Okay? 24 hours, midnight to the next midnight. So how much of Earth's history do you think humans have been around for? Well, most of this day would seem empty. At 1 or 2 in the morning, the Earth is just lava, volcanoes everywhere, totally inhospitable. That means nothing could live there. Single-celled organisms appear around maybe 4 in the morning and slowly creep towards multicellular organisms and very simple plants. That's it. That's the whole day. From 4 in the morning until almost 8 at night, the Earth was just a simple ocean, full of invertebrates and microscopic life. That's it. We don't even get any simple animals, like mollusks or this sea cucumber, until almost 9 o'clock at night. 9 o'clock! There's only 3 hours left in the day. No fish until 10 p.m., no dinosaurs until 11 p.m., no mammals like the Indracotherium, this awesome animal that looks like a rhino and a hippo and a giraffe all in one, or the saber-toothed tiger, whose actual name, I kid you not, was Smilodon. Or later, early horses, for example, leading to Przewalski's horse. We don't get any mammals at all until 11:39 p.m. So, what about humans? We do not appear on this single-day Earth until 11:59. All of human history represents less than 1 minute of Earth's history. Just 1 minute. Wow. Now, geologists and paleontologists use a complex graphic, kind of like our science umbrella picture, but much denser. It's called the geologic timescale. Thank you to the U.S. Geological Survey for this image. Now, the geologic timescale helps Earth scientists divide time up into portions we can wrap our heads around. So in Kingston, all of our rock is super duper old. It's from the Precambrian, which is here, to around the Ordovician, which is here. Dinosaurs, they lived in the Triassic through the Jurassic to the Cretaceous. Now, those are the only periods of the timescale I'm going to be talking about today. Precambrian to Ordovician, and then Triassic, Jurassic, and Cretaceous. But if you're curious, I promise you that every part of this timescale holds amazing, shocking paleontological wonders. You would not believe some of the things that have existed on Earth in the past. So, that was our little lesson on geologic time and the geologic time scale.
Speaking of time, looks like we're running out. Let's get out there. Let's learn about rocks! Woo!
All across what is now Kingston, Frontenac, there used to be an ancient mountain range about 1 billion years ago called the Grenville Mountains. The Grenville mountain range was huge! It started all the way over in Labrador and on the west-north tip of Newfoundland, and it went all the way down across the eastern United States to North Carolina and almost as far as Texas. After the Grenville Mountains eroded, that means were worn down, Kingston Frontenac was covered in a shallow sea. It was warm, tropical, and this was during the period that geologists call the Ordovician. If we were using our single-day clock, the Ordovician was between 9 and 10 p.m. During the Ordovician, a lot of creatures with shells lived in this shallow, warm sea, and when they died, those shells would sink down to the bottom of that sea and be consolidated, kind of pressed and added in to the sand. Now, shells are high in calcium, and basically what happened is the bottom of these seas, the evidence of all of these shallow Ordovician seas, was pressed into a stone called limestone. Now, you've probably heard that Kingston is sometimes called the Limestone City, and that's because there's so much limestone underneath Kingston. But what you may not have known is that that limestone comes from the Ordovician when Kingston was actually a shallow ocean. Finally, after the shallow seas had dried up and geology had changed once again, Kingston was covered in a 2-kilometer thick sheet of glacial ice. We're going to talk more about glaciers and how glaciers affect geology and geography a little later on. Side note, these are metamorphic rocks. It's too loud here to film the full segment because we're by the road. But I wanted to show you how cool this outcrop is. This is marble, and all of these darker chunks, these fragments in here, are a rock called gneiss. Remember that there are 3 kinds of rocks: igneous, sedimentary, and metamorphic. I'm not going to explain the difference of them now, but we might get into it in the live segment on Monday. Metamorphic rocks have really fun names, like schist and gneiss. Gneiss is actually spelt like this. Kind of like gneiss, but it's actually pronounced nice, which is fun, because nice is nice. This is another outcropping of gneiss, except this has a rusty red coloring caused by the weathering of iron sulfide.
This is some nice rock.
Kingston is also situated on something called the Frontenac Arch, or the Frontenac Axis. This is a spine of Precambrian granite that connects the Canadian Shield all the way down to the Adirondack Mountains in New York. Not only is the Frontenac Arch a super cool geological feature, but it's also part of a unique biosphere. Like interconnected habitat. Think of it that way.
As you can see here, I'm standing on a large, soft slab of stone. What this is, and what this can tell you, is that this is clearly a formation caused from some glacial activity. So what a glacier is, it's a giant, massive moving piece of ice. A long time ago, back in a time that we call the Ice Age, is when all of the continent we live on, all of North America, was covered in ice. And these giant chunks of ice would slowly recede, as in they would just slowly get smaller and they would move across the ground. And a lot of these times, it wasn't just ice in these glaciers, it was giant chunks of rock that were moving with the ice and with the land. A lot of the times, this rock gets left here. This rock right here, for example, is very smooth, and you can see the grooves on it are clearly caused by the glacier moving across the ground. And then another fascinating formation that you can find here, this right here, it doesn't look like much, but it is the beginning of a formation of something that we call a kettle. What that's caused from is a lot of the time when the glacier melts, water runs underneath and through the glacier. A lot of the times when the water runs into the ground, it will make a swirling formation, almost like a whirlpool or some water going down the drain in your bathtub. and that will make a circular tube-like formation in the rocks. This is just the beginning of one, but I'm sure if you look around you can find a whole bunch around here.
Okay, now it's what you've all been waiting for. Dinosaurs. I love dinosaurs. When I was a kid, I had two passions, horses and dinosaurs. And girls, if anyone tries to tell you that you can't like dinosaurs because it's a boy thing, that is a lie. You can like dinosaurs and also rocket ships and science and math and getting dirty and playing sports and really whatever it is you like. I love dinosaurs so much. I mean, how can you not? They are the coolest things ever. But why can't we find any dinosaur fossils in Kingston? In fact, why can't we find dinosaur fossils anywhere in Ontario? Well, remember that geologic time is so much longer than the human mind can comprehend. Things that seem really permanent and solid to us, like rocks, have actually moved and changed, been shaped and scraped and reshaped over millions of years. So in Kingston, the fossil record that we are left with is all from those early rocks, those Ordovician marine seas like I talked about earlier. Now, there were dinosaurs in the land that we now call Canada, primarily out west in Alberta and Saskatchewan. Alberta is the kind of place where dinosaur skeletons have been found by people just in their farm fields. Some of the most famous dinosaurs that we found in Alberta and Saskatchewan include Ankylosaurus, which is sometimes pronounced Ankylosaurus, and T-Rex. Yes, we have found T-Rex fossils in Canada. There's also a dinosaur called Albertosaurus, which is literally named after the province of Alberta. In the Bay of Fundy, which is famous for its high tides, we have also found the Triassic fossils of a prosauropod called Plateosaurus. Lastly, out in BC, they've found remnants of a dinosaur called Elasmosaurus, which is a form of plesiosaur. A plesiosaur is the long-necked swimming dinosaur. So even though we can't find dinosaurs in Ontario, we can find fossils in Kingston Frontenac. I've actually found many fossils just walking along the shoreline down by where Queen's and Kingston General Hospital is, and it wasn't hard. You can go out and find fossils in Kingston yourself. But they're probably not what you're expecting when you go out looking for fossils. So that you know what you should be looking for in Ordovician fossil hunting, I'm going to show you some of the fossils I found real quick. So you'll notice that all of the Kingston fossils are on the same kind of gray stone. And that is because, of course, they are all limestone. Start with this one. This is a gastropod fossil, so you can see the spiral here of the shell. A gastropod is like snails, for example. So this is an early snail shell. This is a trilobite. This is, I think, the coolest fossil I found in Kingston. Trilobite fossils are the rarest ones, they're hardest to find, but there were a lot of them living in the Ordovician. And you can see maybe, I don't know if you can see it, but the sort of ribbing on its shell there, the lines, that's because a trilobite was able to curl itself up into a ball, kind of like an armadillo or little roly-poly bugs, right? These final fossils, these are all crinoid fossils, and crinoids are the most common fossil you're going to find in Kingston, but most people don't even realize that they are fossils. So this is what a crinoid looked like when it was alive. Kind of like a weird bony flower, right? But when crinoids died, those little round discs in their stem would break up and be kind of scattered all across the sand. So you can see here, all of these little discs in this stone, those are all pieces of crinoid. This fossil is a little bit more rare because this has the imprint of an intact crinoid stem. So if you find an intact crinoid stem like this, that is pretty darn cool. So crinoids are super common, but you might also find some snail-like shells imprints of shells that look like they could have come from clams or other similar bivalves, shellfish, stuff like that, or really cool things like trilobites. Okay, so your challenge this week is to learn more about something from this episode that really piqued your curiosity. I feel like a lot of people don't know a lot about geology or the geologic history of where they live, and it can be so cool. Maybe trilobites sounded really neat to you, and you want to learn more about all the different kinds of trilobites that have been found all over the world. Or maybe you just think dinosaurs are amazing, which they are, and you just want to learn more about them. If that's the case, I challenge you to learn about a dinosaur you've never heard of before. So no, it can't be T-Rex, or Triceratops, or one of those long-necked dinosaurs that everybody knows. I want you to find a dinosaur that even your parents have never heard of. My favorite dinosaur of all time is the Brachiosaurus. How can you not love the Brachiosaurus? They're like these gentle giants. But my new dinosaur that I just learned about is Therizinosaurus, which had these crazy, like, claw things that it used to gather foliage towards it, like plants and leaves. How cool is that? Now, to do this learning, you need some resources to help you with your research. All good scientists and naturalists do research and know what's a good resource and what's a bad resource. Of course, you always have Google. Make sure to check with your grown-up before using the internet, of course. I also have some really cool books that I want to recommend, including this Dinosaur Bones and What They Tell Us by Rob Colson, 20 Fun Facts About Fossils by Janie Levy, this Rocks, Minerals, and Fossils book by Firefly. It's a really beautiful, like, glossy book. I want to read it. And also, this is my favorite of all time, Geology Lab for Kids. This is just full of experiments and things you can do hands-on that all have to do with learning more about geology and the forces of the earth. And yes, I'm pretty sure making a volcano with baking soda and vinegar is in here, because I mean, how can you pass up that one? I also recommend the YouTube channel PBS Eons. There is a lot of complicated science on that channel, and it might be a little bit old for some of you, but if you're super into geology and learning about the ancient past, PBS Eons does have some really cool videos that explains like ancient animals and the way that geologic time works and things like that. So it's definitely a resource that could be cool to check out. Also, don't forget that Queen's Geology Department has a museum. It's not open right now because of COVID-19, but when it does reopen, the Miller Museum of Geology is top shelf. I love it. They also have an interactive topographic sandbox, which, if you've never seen one, look it up. It is so cool. The Miller Museum also has a huge collection of fossils, beautiful minerals, and even some dinosaur bones. It's definitely worth taking an afternoon to check out sometime. Remember, as we're learning about nature, use all the resources around you, and if you find something that's really cool, let me know about it in Words from the Wild live on Monday. I'd be happy to answer questions, and we can go over all sorts of cool things you've learned and your new dinosaurs.
That's all the time we have for today, friends.
Stay wild!